Okay, we're welcome to tutoring with Schmidt, and so we have a look at our quiz for tomorrow on Friday, January 17th, and it's looking at type 1 cations and polyatomic formula units. So let's go ahead and get started. As we go along, I'd like for you to try to do these on your own. So pause the video and see if you get your answer correct, and then we'll go over the answer. So I'll let you know a good time to pause. So let's look at these first three. You might pause the video, try answering those, and then come back and I'll have some answers for you. So take some time and pause and try to come up with the answers to these three. Okay, so when we're looking at this, all we're doing is naming the cation and then the anion. And so when we do that, oops, we have in purple the cation, and it must always be named first. So if you look up the name of CS, it is cesium. And if you look up the name of the anion, it is fluoride. Must have an IDE ending. Some people have been putting fluorine. That is not correct. Okay, guys? So make sure you have IDE ending, especially when you have a monatomic anion, meaning that's only made up of one element or one atom. And fluorine is the only atom in the anion, so uh, uh, so it becomes fluoride as it forms an anion. As an atom, it is fluorine. As an ion, it is fluoride. Okay, we go to the second one. And if you look at your polyatomic ion sheet, you will find that this right here, NH4, that is ammonium. So all we do is write ammonium. And then you write the anion, which is, I'm going to use a better color here, O. Notice it's monatomic again, only one type of atom. And so we have to put this "ide" ending on it. So it is oxide. And you're dealing with a multiple choice question, so these should be easy to figure out. Always make sure you're putting cation, then your anion. So they should be in the same order that they're listed on your in your question. So you see cesium is listed first, cesium is named first. So make sure you watch for that. All right, and then the last one, fairly easy one, we have sodium. So sodium is Na, so we write sodium. And then we just have to find the name of this OH. And if you go to your polyatomic ion, it's really the only polyatomic ion. Well, there's two of them. I think cyanide has an IDE ending, but so does hydroxide. But anytime you have a polyatomic ion, either way, you just give it the name that's written. So you just write hydroxide. And so can't get those wrong if you do it that way. Okay, moving on. Let's try these two on your own. You might go ahead and pause the video, try those, and then we'll come back and answer those for you. Okay, hopefully by now you have already tried these on your own. These match very closely to what's on your quiz, so I hope this works out for you. But you have strontium. Strontium is SR, and now you're going to write the formula unit. So you're going to write the formula unit, you have to make sure you're looking at the charges. So the charges are strontium, and if you look at your periodic table, it's 2+. You have to find the formula for nitrite. Notice that it says ite. There's nitride, nitrite, nitrate. So you have to look at all of those. So nitrite is NO2, 1-. Now what you want to look at are the sum of your charges. This is 2 and this is 1. If you add those together, they will not equal 0. The idea here is that the sum of the charges, or when you add the charges up, they must equal 0. And so in order to make that happen, what we do is we will put a parentheses always around our polyatomics. It's the first thing you do. If you have a polyatomic and the charges don't equal 0, put a parentheses around, and you will take the 2 here, and not a 2 plus, but just 2, to show that there are going to be 2 nitride ions, and you're going to move the 1 here to show that there are 1 strontium ion. So what that looks like is 1 strontium ion with the 2 plus charge, and it looks like 2 nitrite ions, each with a 1 negative charge. And so if you add up 2 plus -1 plus -1, that equals 0. Now, there's no requirement to write this picture on your test. There would be a requirement to show this step here, because it's really the only way you're going to make sure you get the right answer. So make sure, even though it's multiple choice, that you do this step and then just match your answer with what we have on the test. So you're looking at 1 strontium, SR. You see the 1 here. And then you have a parentheses. You must have the parentheses, NO2, and then there's 2 of those. You would not write SR NO2 2. That doesn't happen. And quite frankly, we can't put that on a multiple choice test because it's impossible to type that. So, but if we were to ask you to write something in a short answer, that's the way to do that. Okay, and so that would be your answer. And hopefully that's what you got. And then next you have calcium sulfite. Sulfite. So make sure you're understanding, again, the ending is ITE. So you're going to pay attention to that when you look it up on your polyatomic ion sheet. And we have calcium with a 2 plus charge. And you have sulfite, which is SO3, and it has a 2 minus charge. Yeah, and you might be weirded out that my 2's look different. I'm sorry, I just found out today I do that. So what you're looking at here is the sum of the charges, 2 plus and 2 minus. They already equal 0. In this case, there is no need to do any of this switching stuff. You don't need to do this when, whoops, I don't know what happened here, when the charges sum up to be 0 already. Evidently, there's something wacky happened with my pen. So the sum of the charges equals 0 already. You just write it as it appears, CaSO3. And that is as easy as it gets. It means you have 1 calcium ion. You don't have to show this picture, but this is exactly what it means. 1 calcium ion with a 2 plus charge, and 1 sulfite ion with a 2 minus charge. 2 plus -2 gives you 0. All right. And then we have, look at this, another something with sulfur. We have now sulfide. See the IDE. So when you see the IDE, that's a monatomic most of the time, except for hydroxide and cyanide. But here, when you're looking at sulfide, that is going to be, got some extra 5s in there. So when you look at sulfide, that's going to be sulfur as an ion. So you look at calcium, Ca, 2 plus, and you have sulfide, all right, S, 2 minus. And again, the sum of the charges equals 0. 2 plus -2, so you just write it as it appears, CaS. All right, and then number 7, we have aluminum sulfate. So now pay attention to this. We have 8. Got to make sure you look that up on your polyatomic ion sheet. So we look at aluminum, Al3 plus, and sulfate is SO4, 2 minus. Now you will notice that 3 plus -2 does not equal 0. So we must make those charges equal 0, and we do that by switching. But before we do, because they didn't equal 0 and you have a polyatomic, you must put a parentheses. So you put a 2 here, and you put a 3 here, and all that means, all right, all that means is you have 2 aluminum ions, each with a 3 plus charge, and you have 3 sulfate ions with a 2 minus charge. And if you add all these charges up, 2, 2, 2, it's going to get you -6. And if you add these up, 3 and 3, you're going to get +6. And 6 plus -6 equals 0. So the sum of my charges equals 0. That means I did this correctly. So all I have to do is rewrite this. Now, there's an easier way to maybe look at that. You could look at it in terms of there's 2 times 3, 3 plus, and so you could think of that as being 6, and you have 3 times -2, which is -6, and so your sum of your charges equals 0. My 6s didn't pair up very well though. So 2 times 3, 2 times 3 is 6, and 3 times -2 is -6 for a total of 0. Okay, so you can use your picture or you can look at it that way. Pictures are going to be a little bit slow moving forward though. So we rewrite this Al2, because that's what we show in here. And then we have to have a parentheses, SO4, 3. And that's got to be a parentheses because we have more than one sulfate ion. We have 3 of them. If there's only one, we don't need the parentheses, but we have 3, so we have to have the parentheses. So what you should have got is that. All right, now take some time to pause and do this last one. Okay, hopefully you have come up with your formula. And so ammonium is NH4, and that is a polyatomic. And then this is phosphite, PO3. And ammonium is 1 plus, and phosphite is 3 minus. Now, if you notice, both of these are polyatomics. And the sum of the charges, 1 plus -3, does not equal 0. So the first thing we do is we put a parentheses around both of them. And so we did. And then now we can switch. 3 ammonium ions, 1 phosphite ion. So, and all that really looks like is this. It looks like we have NH4, 1 plus, NH4, 1 plus, NH4, 1 plus, and then we have 1 PO3 ion with a 3 minus charge. And once again, when we add these up, 1 plus 1 plus 1, that gives us 3. And maybe I'll use a different color. Whoa, I think I may have got rid of some stuff. Maybe I use green. This is 3 and plus -3. See the -3 I'm talking about there, and that is 0. All right, so all you have to do is rewrite what you already had. I erased that little line there. And when you rewrite that, all you're going to get is NH4. You have to put the parentheses because there's more than one, 3, and then PO3. You can put a parentheses around this too. It's not wrong to, but if you look at your picture, you have 3 NH4 and 1 PO3. Another way you can write this is NH4, 3 with the parentheses, and PO3 without the parentheses because you only have 1, right? You see 1 in the picture. And so both of these are correct. And the way it'll probably be written on a test will be if there's not a parentheses required, we don't put it on there. So anyway, I hope this helps. And I hope you do really well tomorrow. Thank you for watching. Please tell your friends.